Hello guys, in this video, I with my friends of my group will explain you about derivative of two variable function. The first one, we have Cartesian coordinates in 3 space. We know if we have f function f x y will result in z coordinate and in z axis. And the next one is the distance of this function is equals to root square of x1 minus x2 square plus y1 minus y2 square. And this is the illustration of the distance from this function. We know the x and y is the domain of this function, and the z is the codomain of this function. The next one is 3D shapes. We know we have many 3D shapes. The first one is sphere with general formula x minus h square plus y minus k square plus z minus l square is equals to r square, with r is the radius of this sphere. The next one is ellipsoid, 1-leaf hyperbolic and 2-leaf hyperbolic. From these 3 shapes we have the similar general formula x square over a square, y square over b square, z square over c square is equals to 1. But the difference of these 3 shapes, if all ellipsoid, the sign will be positive and positive. For 1-leaf hyperbolic, the sign will positive and negative, and for 2-leaf hyperbolic, the sign will negative and negative. And for elliptic cone, the general formula is similar to these 3 formula, but it equals to 0. And for ellipse parabolic and hyperbolic parabolic, we have also general formula x square over a square, y square over b square is equals to z per c over c. And for ellipse parabolic, the sign will positive, and hyperbolic parabolic, the sign will negative. And for the example, determine the function of fxy 3x plus y square. Now, from this equation, we must to determine the domain of this function, and the domain is xy is all elements for L square. And this is the illustration of the graphic. And the second one, find the central point and radius of this function, and we can substitute this function to the general function like this, and we get the radius is 8 and the central point is -4, 2 and 11.
So the next topic is about limit and continuity of two variables. In this topic, we're gonna use 3 theorems. The first theorem is this: if limit of a function x and y, and that x and y goes to ab, it equals fab. And if fxy equals to pxy over qxy, then if ab is not 0, it equals, then it means limit of fxy is equals pab over qab. And if pab is not 0 and qab is 0, that the limit of fxy equals, it doesn't exist. So the second theorem is about if a function of g with 2 variables continues at ab, and a function f with 1 variable, either if it's fx fy continues at ab, then the composition of these two functions fog xy it equals fg xy. That function will continues at ab. And the last theorem is this theorem: if fxy and fyx continues at an open set of S, then fxy equals fyx at each point of open set S. And this is some examples. So the first example is a limit of a function x squared y plus 3y and the xy goes to 1 2. So we're gonna substitute the x and y with 1 and 2 and it goes 8. And the second example is limit of x squared plus y squared plus 1 over x squared minus y squared with the x and y goes to 0. Substitute the x and y, it's gonna be, that limit is not gonna be exist. And the last example is if a function of xy equals to cosine of x cubed minus 4xy plus y squared, and it will, so the function will continuous for all xy. Why? Because this one is polynomial, and this polynomial continues for all x and y. So this function will continuous for all xy.
Next, I'll be explaining how to derive the two variables equation. We know the notation that fx dx or d per dx means the derivation toward x. Meanwhile, fy dy or d per dy means the derivation towards y. We use the partial uv formula where the derivative of f uv equals to the derivative of u multiplied by v plus the derivatives of v multiplied by u. And for the derivatives of u per v, we use the derivatives of u times by v minus by derivative of v times by u over v square. Multiple derivatives you can see here, like the function f is the derivative is toward x and then towards x again. If here fxy, first you derivative the function towards x and then you do the derivatives towards y. Example for the partial uv formula, and this is the example for the multiple derivatives. First you do the f toward x, the derivative toward x, and then you put this into derivatives towards y. And then the next is chain rule derivatives. We know that dz per dt equals to dz per dx times by dx per dt plus dz per dy times by dy per dt. So this is the example. We know that z is x times by y square with x is 2t square and y is t cubic. We first should find the element of dz per dt, and then we put them back with x is 2t square and y is t cubic. We put them back to the t variable. So this is the result.
The next chapter is about directed and gradient derivatives of two variables. Propose change I of t with any vector u. Evaluate this formula. Example: if f x y for x square mean xy plus 3y square. Find the derivative f into mean 1 on the vector directions of a for e plus 3e. Answer: vector u for a root of 2 quadrat min 1 quadrat, comma 3 per a root 2 square plus min 1 square, 4 per 5e, 3 per 5g. fx x y x min y and fy x comma y is min x plus 6y. So fx2 comma min 1 17. With same way for y. So term A d2 comma min 1 you can find it.
Today I'm going to explain you about the maximum and minimum point of two variables function. In this section, we have the formula to find discriminant of the function. And there's four conditions to find which is the point, whether it's local maximum, local minimum, or saddle point. When discriminant is equal to 0, it is inconclusive. Here's the example of the maximum and minimum point. Find the extreme point of function equals to 2x to the power of 4 minus x squared plus 3y squared. The answer is find the first and second partial derivative, which you can see it's in here. We already listed it. Then we find the first derivative of x and y equals to 0. And the first derivative of y, x and y equals to 0 too. Then we find 3x, which is 0, plus half and minus half. Then we find the y is only 0. Then we have three critical points, which we're going to input into this formula and into the second derivative of x, which we are listed in here. Then we find that the 0.0 is saddle point, half point 0 is minimum point, and minus half point 0 is minimum point 2.
Hi, my name is Adina Fatima Zahra, and now I'm going to explain about the maximum and minimum local value. To find the maximum and minimum local value, we can use two options, two ways, which is the first one is theorem A, or we call it the maximum and minimum existence theorem. The theorem has conditions, which is f is always have to be continuous and the set S must be a closed interval. The theorem A has types. The first one is endpoints, and then the second one there's stationary points, and the last one is singular points. And then there's theorem B, or we can call it critical points theorem, which has the definitions of f is defined in interval I containing point C. If function C is an extreme point, then C must be a critical point. C is either endpoint of interval, stationary points of function f accent C equal to 0, singular point of function f accent C equal to 0, which is not exist. So this is the example. Find the local maximum and minimum value of function x and y. First of all, the given function can be differentiated along the area of origin, the xy plane. So the only critical points are obtained by setting the function x and function y equal to 0. However, function x equal to 2x minus 2 and function y equal to y per 2 equal to 0. It's only happen when the x is 1 and the y is 0. So then we can find the function of 1.0 equal to minus 1. We substitute all of the function given, and then we can know that the function 1.0 is actually a global minimum for f, and there are no local maximum values. Thank you.
Good afternoon, my name is Akar, and now I'm going to explain about chain rule. So chain rule is a method that is used to resolve derivative of function consisting of composition of two or more functions. And the composition of function is usually derived by chain is a function that has rank of. And if y equals fx is a function that can be derived against u, and u equal to gx is a function that can be derived against x. So y equal to f composition and gx the composition of x, and can be derived by the following rules. And for example is this. Example is number 1, y equal to sinus power 3 to x min 3, and let's assume that sin is u and v is 2x minus 3, and we substitute to the formula and we get this, and then this.
Hello, in this section we're going to talk about rank method. This method is used to find the maximum and minimum values of the function. Gradient f function is equal to lambda, the gradient of g function, and g function is must be equal to 0. For the example, let's find the maximum and minimum values of f function is equal to x squared minus y squared plus 1 in circle x squared plus y squared plus x equal to 1. So the gradient of the function is fx I plus fy j. So the gradient of the function is 2x I min minus 2y j, and the gradient of the function is 2x I plus 2y j. Because the 2x is equal to lambda 2x minus 2y is equal to lambda 2y, and the x squared plus y squared is equal to 1. For the x is not equal to 0, we gonna get this data point 1.0 minus 1.0, and for x we gonna find this data point 0.1 and 0. minus 1. Substitute to the function. For the function 1.0 is equal to 2, and minus 1.0 is equal to 2. 0.1 is equal to 0, and 0. minus 1 is equal to 0, and the result is maximum value of 2 is 2 in 1.0 and minus 1.0, and the minimum value is 0 in 0.1 and 0. minus 1.